Hi, welcome to this session, which will be an introduction to welding and grinding here in the welding and fabrication room inside the mechanical engineering labs. We'll go through various things, starting off with health and safety, and then we'll go on to cutting some metal, to grinding some metal, and then I'll give you an introduction into the different types of welder that we have, and then we'll actually do some welding. So first, the first thing that we need to start off with, which is the most important thing, is health and safety. So we have a risk assessment form here which explains all the different hazards within this area. So specifically with this area, it's very important that we follow all the proper health and safety procedures because serious injury can occur if we don't follow them. So first on our risk assessment list is hand, hair or clothing entanglement. In this lab, there's lots of rotating equipment. So this cutoff saw, for example, rotates at very high speed. So if, for example, I had a chain which is hanging down loose here, or my hair was long and was hanging down here, and it got caught in this rotating equipment, it's going to pull it into there. It's going to pull my hand in there, or it's going to pull my head in there. So we need to be really careful that we're not wearing any loose clothing, no ties, no loose hair, no chains, anything like that. So that's very important. The next thing we've got is electric shock. So the welders are very high current. They produce a lot of electric power. So before we use them, just make sure everything looks okay. There's no frayed wires and things. Same with these saws. Make sure the wires are in good condition. They're checked regularly by the technicians, but before you use any equipment, it's always a good idea to give it a quick check over. Next, we've got ultraviolet radiation and sparks. So when we're using this or we're using the grinder, it creates lots of sparks. So that's a hazard to us. So we need to make sure we're wearing all the proper equipment. Make sure all our bare skin is covered up properly. Then we've got ultraviolet radiation. So the welders produce UV light just like the sun. So it can damage your eyes. It's very bright light. So we need to make sure our face is covered, and we do that by wearing a welding mask such as this. I'll explain that a bit later. This is the welding mask. And also it can burn our skin. It's very bright light, so like if you're out in the sun for a long time, it will burn your skin and make it red, so make sure all our skin's covered. Next, we've got hot surfaces. With the grinding and the welding, it's going to create very hot metal. So always be aware of that. Never pick anything up without wearing the appropriate gloves, and be careful that we don't drop things on our bare skin. Fumes. When we weld, there are various gases that are given off from the welding, and different types of metal give off different fumes. Some metals might have some paint on them. They may have some chemicals on them. So we use a fume extractor. I'm not sure if you can see those here. We use these fume extractors. If you are in the lab, in the welding room for a long period of time, also a face mask would also be useful as well. Next, compressed gas. So these welders use gas bottles. The gas inside the bottles aren't flammable, but it's a very high pressure, like 150 bar of pressure. So it's very, very high pressure. So we need to be aware of that. Listen out for any leaks or anything. Make sure the bottles are stable and that they're not going to fall over. They won't be knocked over. Then the final thing is electronic medical equipment. So if you have a pacemaker or any other electrical device that might be affected by the electromagnetic radiation emitted by the welders, then you should always let someone know before you use the welders and make sure it's safe to use them. So that's the health and safety aspects. I'll go now and put on my health and safety gear, and you can come back to me then. So now I'm fully dressed up in all my PPE gear. I've got leather boots on, steel toe cap boots. So any sparks, for example, will not burn through. If, for example, I was wearing trainers, the sparks and the hot melted metal might go through the trainers and burn my feet. So my feet are protected with the safety boots. My legs are covered with trousers. I'm wearing this leather apron, which protects against sparks and hot metal. My arms are covered in these leather sleeves, and I've got tight fitting gloves on. I'm also wearing safety glasses, and additionally I have a face shield which I'll wear when I'm using this equipment, and some ear defenders as well. Okay, so now that we have all our PPE prepared, the next thing we need to do is prepare our work area. So we know that this is going to create a lot of sparks and heat, so we need to make sure anything like paper, for example, is well out of the way. Make sure there are no rags, make sure the area is nice and clean and tidy before we start. So this is what is commonly referred to as a cutoff wheel or a cutoff saw. Technically, it's not actually cutting the metal, it's grinding the metal. This is a grinding disc and it grinds through the metal. Before you use any equipment, always check the condition of it. Make sure that the guards are in place, read through the safety instructions which are on the side of the machine. Make sure the machine looks in good condition, because you don't know who's used it before it and whether they've been using it correctly. So inspect the disc, make sure there are no cracks, no foreign materials inside. I'll show you some examples. So this, for example, you can see this is a disc that was on it previously. This has a big chunk missing out of the side of it. This was caused by somebody forcing the disc down at too fast a speed, and it's caused it to shatter. So this piece of material will have spun around inside this cover and then flown out to the side. So we don't want that to happen. So if you see anything like that, then don't use the machine. The same with this. If you can see there are little shiny bits of metal in there. That's aluminium. With these discs, we only cut steel. What will happen here is this aluminium, when you're cutting through some metal, the aluminium will expand because it's stuck inside the pores of this grinding disc. As the aluminium expands, it will cause the disc to crack and then shatter, and then the disc will basically explode, throwing material everywhere. So if you ever see that, then don't use the machine. So now we've inspected the disc, we're happy with that, we're happy that the guard's in place, the wire looks in good condition, the area's nice and clear, there's no risk of any fire or anything like that. So then what we want to do is make sure there's nothing loose, nothing's going to get entangled in here, my sleeves are nice and tight, my gloves are nice and tight, because we don't want any entanglement. We then use a face shield because my eyes are protected with the safety glasses, but I also want to protect my face using a face shield. So I always wear a face shield additionally to the glasses. And then because it's quite noisy, I put some ear defenders on, especially if you're going to be working in this area for a long period of time, then you want to protect your ears. So this is the piece of steel that we're going to cut. It's just flat steel bar. And we place it inside the clamp here, into position there. We check the distance that we want from here, so about that much, and then we tighten it up using the screw clamp here, making sure it's nice and flat and nice and tight. Okay, so now my piece of metal that I'm going to cut is safely clamped in here, nice and tight. And then I'm ready to start cutting. Okay, so now we've cut off our piece of metal and we've left it a couple of minutes to cool down. We can see that it's got some bird edges, some sharp edges, so that's one reason we need to wear our safety gloves. But we want to remove these edges because we want to prepare this material for welding. So we're going to do that by using the bench grinder. So I'll show you how to use the bench grinder and also the belt sander at the same time. So when we're using this machine, as with the cutoff wheel, the first thing we want to do is just inspect the machine, make sure that the guards are all in place, and inspect the grindstone. We want to make sure there's no foreign objects stuck in the grindstone, no cracks, make sure that's in good condition. Then when we come to grind the metal, we want to hold the material as far away as we can. So we want to be as far away from the grindstone as possible. We want to make sure our gloves are tight-fitting gloves. Some people actually recommend not wearing gloves at all, just to reduce the risk of our gloves getting entrapped in here and our hands getting pulled in. But because these are nice tight-fitting gloves and we've got some distance on the material, then we can hold it at the end, nice tight grip. Hold it at around 45 degrees to the grindstone in this direction. We don't want it to be at a steep angle like this, because the grindstone will catch it and pull it out of our hands. So we want to be around 45 degrees like this and go gently from one side to the other, allowing the material to be removed. We never keep grinding something in the same spot, so you would never hold it like this, for example, and keep it grinding there, because it will wear a groove into the grindstone, which isn't good practice. You want to have the grindstone nice and smooth across all the surfaces. Once we've ground it off with the grindstone, we can then move to the belt sander. The belt sander is more of a finishing tool, so it'll just put a nice finish on it. The way we use this is by holding it again around 45 degrees, but in this direction. So we're holding it like that, so the belt's going this way and the material's going that way, so it's not catching it and pulling it out of our hands. So around this angle, again a nice tight grip, close to the end, and just gently go from one side to the other until all our sharp edges are removed. Okay, so now we can see all the sharp edges have been removed. This material is still a little bit warm from the grinder, so just be aware of that in case you take your gloves off. As you can see, this has all been ground down, so now you can see the nice shiny silver metal. The reason that's shiny silver and this is grey here is because this grey part is what they call mill scale, which is a byproduct of the manufacturing process. When the metal comes out of the furnace, it forms a hard coating around the edge, which is called mill scale, which is this grey section here. So when we're welding, ideally we want to remove this mill scale, especially if we're doing precision welding, welding that needs to be very strong. Then you want to prepare the surface and remove all of this grey mill scale before you start welding, so that the edges look like this one here. Okay, so this is a gas welder, also referred to as an Oxy Acetylene Welder. It uses two gas bottles, one with oxygen and one with acetylene. To use this, you open both the taps on the gas bottles and allow the gas to come through and create a flame here. You then use this flame to melt the metal that you're welding, and as the flame heats up the metal starts to melt, and you gradually work along the material and add filler wire with your left hand. Some of the advantages of a gas welder are that you don't require an electricity supply, so if you needed to weld in a remote location, then this will be good for that. You can also use gas welders for heating up metal, so if you had a bolt which was stuck and you couldn't remove it, then you could heat up the metal with the gas welder to make the bolt easier to remove. You can also use it for cutting metal as well, so if you have a big thick piece of steel, then you can heat up the flame on this to such a high temperature that it will actually just cut straight through the metal. So it's useful in that sense. The downsides are that you need to keep refilling the bottles, which isn't ideal, and also having a hot flame is also a bit of a safety hazard. So we don't often use these welders. We tend to stick to the electric welders because they're much more convenient to use. So the next welder we come on to is the stick welder. One of our 3 arc welders, because that uses an electricity supply to create the heat to melt the metal. It's called a stick welder for obvious reasons, because you use a stick during the welding process. The stick just clips into the handle here, and then you have an earth cable. The earth cable connects to whatever it is that you're welding. The electricity supply then flows down through the handle, down through the filler metal, into the workpiece, and then down through the earth cable to complete the circuit. Stick welders are commonly used on construction sites, kind of industrial use. They're not really for high precision welding. They're quite basic. The only control you have over them is the amperage supply, so you'd increase the amperage the thicker material that you're using, reduce the amperage for thinner material. What happens is that this stick is the filler wire. So as you push into the metal, this filler wire starts to reduce in size and get smaller and smaller and smaller as you go along. Once you get right to the end, you throw this away and you put a new one in, and you can continue welding with that. This green coating that you can see on the outside is in order to shield the melted metal. You need to protect the melted metal from oxygen when you're welding, and this ceramic coating around the outside of this stick is what is used to do that. On the other welders, which I'll explain in a minute, they use gas to shield the metal. We need to shield the melted metal from the oxygen, because if we don't, it becomes porous. So it has lots of little holes in it, which makes the material brittle. So as this filler wire, this filler rod is melting, the ceramic coating is also melting, and then that's pushing away all the oxygen and protecting the melted metal from the oxygen. So that's stick welding. Okay, so next we'll move on to a TIG welder. It's kind of at the opposite end of the scale to the stick welder. You use a TIG welder to do kind of high precision welding. You can use it to weld steel or aluminium. The way it works is electricity comes down through here, down through this metal in the middle, into your workpiece, and down through the earth cable again, and back to the machine to complete the circuit. The reason it's called a TIG welder is that the T stands for tungsten, and the IG stands for inert gas, which comes in the gas bottle here. And the electrode in the middle is made from tungsten, because it's a hard wearing material. These are slide in and out of the torch, and you need to sharpen them or shape them in different ways depending on what it is that you're welding. You also, with a TIG welder, you need to use a filler rod or filler wire, which is like this. It's a copper colour. It's actually made from steel, and it's just coated with copper. They coat it with copper to protect it from rust and corrosion, so that's why it's that kind of bronze colour, but inside it's just regular steel. Again, because it's an arc welder, we need to complete the electric circuit, so we have a big earth clamp here. We clamp this onto the material that we're going to be welding, or onto the table if the table's metal, and then the electricity flows down through the tungsten, through the workpiece, down through the earth clamp, and then back to the machine to complete the circuit. So this TIG welder uses just a push button on the top here, which clicks on and off. But a lot of the time TIG welders will have like a throttle pedal. So it's just kind of like an accelerator pedal in a car. When you increase the force, and it increases the power coming through the TIG welder, so you get much more control over the amount of power that's going into the workpiece. You can increase the power and reduce the power just by lifting on and off of the throttle. So TIG welders are good if you need to do any kind of high precision welding. You can be very accurate with them. You can control the heat a lot more. So when you see things like roll cages or a lot of car parts that are fabricated very neatly, they'll always usually be done with a TIG welder. And TIG welders are almost always used for aluminium welding. So on the machine here we can switch between AC current to DC current depending on whether we're welding aluminium or steel. There are various other settings for the gas flow, for the power, and for the amperage along here. They take a lot of practice to get good at them. There's lots of different settings and different types of tungsten and all different combination of things that you need to really become an expert on in order to be able to become a good TIG welder. Okay, so the final welder that we have is the Mig Welder. This is the one that we use most commonly, because usually we're just welding steel, and it's possibly the easiest one to learn, the quickest one to pick up, and it's nice and convenient to use. There's less preparation, things like that. So it's called a Mig Welder. Mig stands for metal, because the electrode is made from metal, whereas with the Tig Welder the electrode was made from tungsten. So the M is for metal, the I and G is for inert gas. So this is the inert gas. In this case, it's a mixture of argon and CO2. So before, when I was explaining with the with the stick welder, that we need to shield the melted metal from the oxygen, this is what this gas does. So because argon is heavier than oxygen, as we melt the metal, the argon gas flows down through the torch and comes out through here and flows out of the nozzle and pushes the oxygen out of the way. So you can feel the gas blowing out of the end of the gun here, and it's blowing the oxygen out of the way and shielding the melted metal from the oxygen and stopping the metal becoming porous and pitted and making it fragile. So that's the purpose of the gas, and that's why it's called a Mig Welder. Metal referring to the electrode, and IG, the inert gas, referring to the bottle here. With the Tig Welder, it's similar to this, except instead of a mixture of argon and CO2, it's 100% argon. You can vary the mixtures of things. So for example, depending on the material that you're welding, if you are welding some thin sheet metal, for example, then you maybe want to have a higher percentage of argon, or thicker metal, maybe a lower percentage of argon and more CO2. So it really depends on what you're welding, and that's kind of where the experience comes in welding. You need to know what power to use, what gases to use, what thickness filler wire to use. So it takes a lot of practice and experience to get good at welding. The Mig Welder, like I say, it's easy to use. You can use two hands when you're MIG welding, so you don't need to use a filler wire with your opposite hand, because the welder actually feeds the wire out for you. So I can just quickly switch it on and show you the metal. So you can see there, the filler wire is actually automatically coming out of the gun. So the electricity is actually going down the filler wire into the metal, or melting the metal, and the filler wire is filling at the same time as providing the electricity to the workpiece. You can change various things on this welder. You can change the speed of the wire, the speed the wire comes in and out. So I'll show you that quickly. So very slowly like that, or very fast like that. We can also provide a delay on the welding, which can be useful in certain situations. And then our third control is the power. The power just goes from 1 up until 6. For 1, it would be for very thin metal. 6 would be more thick metal. So you can play around with those things when you're welding to try and figure out the best settings that you need for whatever material that it is that you're welding. Okay, so this is the gas that we use in the Tig Welder. In this case, it's 100% argon. So we can see from the gauges here, this gauge shows us how full the bottle is, how much pressure is in there. The bottle is held in position with a chain so that it doesn't fall over. If this was to fall over and this brass fitting was to snap off, then it would release all the gas in there, which is at very high pressure. So this shows us how full the bottle is, so we know when to change it. And this one here is the flow rate. You can adjust the flow rate. When you press the trigger on the Tig Welder, then you can see this little ball goes up, and that's the gas coming out. So as your finger's on the button, the gas is flowing out of the nozzle at the end there. Okay, so now we can come on to the welding. One thing we need to do before we start with the welding is change our gloves. So these gloves are leather gloves, so they'll protect us against heat. This also is a leather glove, just a different type. These ones are a bit more expensive, they give you a bit more feel, so I prefer to wear these ones, but you can wear these ones also. So these are the gloves that we need to wear. We also need to shield our face from the UV light. So there are very basic type helmets like this. As you can see, it's very dark in here, you can barely see through it, so it's very difficult to see what it is that you're welding. And also you need to use your left hand to hold it up, so you only have one hand to help you with the welding. So it's best to use one of these helmets, which is an automatic darkening helmet. So this, you can see through the inside. So it's not perfect vision, but it's pretty good vision from the inside. And when you start welding, the helmet has little sensors in it, and it automatically detects the bright light, and it will darken the helmet for you. So this is the inside of the welding helmet. It has various different settings. This is quite an expensive one, so it has a digital display, and you can change the sensitivity, the level of shading, a delay for when it switches on and off. It also has a grind function here, so you can use the mask for grinding metal without it automatically darkening. You can see through the shade here, you can still see through it. When you start welding, that will darken and come completely black. It will look like that, so you'll only be able to see the actual part that you're welding. So yeah, it also has a button on the side so that you can grind metal using this. That switches off the automatic darkening part of it so that you can grind metal without it going dark. So yeah, these are really good, these automatic darkening helmets, and if you're doing a lot of welding, then it's really worth investing in one of these. So yeah, so we're still wearing our leather sleeve protectors to protect us from the sparks and the heat from the welder, our leather gloves, our welding mask, our welding apron, our leather apron, and also make sure your shoes are tied up nice and tight, because often hot pieces of metal can fall down, and I've had it before where metal's actually gone down the side of my boot into your shoe, and then it's burning your foot and you can't get your shoe off, so you don't want that to happen. There are also caps and things that you can wear on your head, because sometimes sparks can go up onto the top of your head. So yeah, there are lots of different things to protect yourself for welding, but the minimum would be gloves, make sure your skin's protected, and definitely a helmet. If you were to look at the bright light without a helmet, it would burn a hole in the back of your eye and damage your eye and cause temporary blindness. So you really should never weld without a proper welding mask. Okay, so now we're ready to do some MIG welding. We've turned on the extractor fan, and we've got our gloves on, and we've turned on the argon bottle so that we've got gas flowing out of the gun. We want to start with the wire sticking out of the end here, maybe say 5mm, something like that. And then when we weld, we want to try and maintain an angle somewhere close to 90 degrees, a bit less. What you don't want to do is come at too low of an angle, such as this, because then the filler wire is going to be going into this piece of metal, but not this piece of metal. We're going to be welding along this edge here on these two pieces of metal. So you want to keep the angle so that the filler wire is going directly into where the gap is. You want to make sure you're comfortable. That's the main thing when you start welding. Make sure you're comfortable in a nice position, because that's going to improve the quality of your weld. I sometimes do a trial run before I pull the trigger, just to make sure I can get the gun in a nice smooth motion, and then I might want to reposition myself to a different angle. It's really important that you can see what's going on. So if, for example, a common mistake people make when they first start welding is they stand right behind the gun like this. In that case, you can't really see what's happening, because all I can see is the back of the gun here. I want to be able to see right at the tip here. I want to be able to see the melting metal, so that I know whether to speed up, to slow down, whether I need to stop and change the welding settings, things like that. So I always try to stand to the side like this, so I can see where I'm welding. I can follow the line nice and accurately, and you want to just bring it along at a steady speed. Another mistake that first time welders usually make is they go way too fast, and they pull it right across like this really fast. You just want to go one side to the other side. You can either push it or you can pull it, whichever you prefer. But the main things are that you can see what's going on, and you go at a nice steady consistent speed, and follow the line as exactly as you can. Now what you need to do in most cases before you start welding is do what you call a tack weld. A tack weld fixes the piece together. So in this case we would do a tack weld in this corner and in this corner, and then that's going to keep the metal held in position. If we didn't do a tack weld and we just started welding from here and we came along like this, then what would happen is the heat would cause the metal to expand and cause it to spread out like this, so this gap would become bigger and bigger as you welded along. There are other things that we can use to stop the metal moving whilst we weld it. There are clamps like these, and there are magnetic clamps like this that help keep your metal in position for when you're welding it. But yeah, doing a tack weld is usually essential to stop the metal moving before you start. So I can show you that now. Okay, so now we've done tack welds in either corner. These tack welds are going to keep the metal in position to stop it spreading out. If we didn't put those tack welds in, then what might happen is the metal might start to spread out at this side. If we came across here and we're welding down here, then the heat might cause the metal to spread out and create a bigger gap. So these tack welds keep it held nice and securely in position. It may also start to bend upwards like this. So in that case, if it was starting to do that, we could use various clamps and things to hold it down to the table to make sure it didn't move and distort as we're welding. Okay, so now we've got our tack welds done, we've got our earth clamp in position, our extractor fans on, so now we're ready to do the weld. Okay, so now we're ready to start welding. I can get myself in a nice comfortable position, somewhere where I can see everything that's going on. I've got nice support, nice control over the gun. A nice steady firm position, and then we're ready to weld. Okay, so this is the weld that we've just done. You can see at the beginning here there's holes in it, so this is the porosity that I was explaining before. So this is the initial part where I started, the gas wasn't flowing out quite well enough, so that's why there's these little holes in there. And then the rest of the weld is okay. It's a little bit high up because the mixture of gas that we're using isn't quite correct for this type of metal. This weld here is a much better weld. This is using the right gas that we need for this type of material. So this is what you want really, ideally like this, not too wide, not too thin, nice and consistent, not too high, not too low. This one, for example, is an example of going way too fast. So they've been holding the gun too far away. You can see all these little spatters of metal. That's caused by holding the gun too far away, and they've moved the gun way too fast. It's not even really on the line properly. This one again is an example of, it looks like the gas hasn't been turned on here. You can see there's lots of little holes in it, which makes the weld very weak. This one again, way too fast. This one is not too bad, but it's not very consistent. You can see they've not followed the line very well. It's kind of wavy. So that's why I was saying you really need to focus on where you're welding and make sure you're following the line as accurately as you can. Okay, so that was the introduction to welding and grinding. There's lots of information to take in, but hopefully some of it will have been useful to you. If you want to learn welding and grinding skills, then it's useful skills to have, especially if you like doing projects and things like that. So yeah, if you ever feel like you want to learn welding and be shown the grinding and cutting equipment, then you can always find one of the technicians and we can arrange a time for you to come and have a practice.